recursive questions. So we're going to move at a pretty good speed here. Recursive functions are built on previous functions. Okay? So if I want a previous number, if I have it at 20 and I want the number before 20, I would just say it's 20 minus 1 to get the previous number. So if I wanted a sub n and I want the previous number, I would do a sub n minus 1. I want the number before. So a recursive sequence is always going to use this previous term. So a quick review. We've done this before. This is already an example we have in our book. We want the first 4 terms. So if I have a sub 1, my next goal would be to get a sub 2. So I'm just going to go to my formula, and I'm going to replace all my n's with the number 2. So take a moment, put all 2's into your n's. 2 times a sub 2 minus 1 plus 5. That becomes, right here, this 2 minus 1 really becomes a sub 1, which is the previous term. And I know a sub 1 is -4, so I can substitute that in. So I've got a sub 2 equals, that's -8 plus 5, -3. And I've got that second term. And then I keep going. It wants the first 4 terms. So I'm going to find a sub 3 next. So I'm going to go to the formula. I'm going to replace all those little n's with a 3. I'm just going to slowly and neatly clean it up. So this becomes 2 times, this becomes a sub 2 plus 5. A sub 2 is the previous term I just found. That's the recursive part of it. So I have 2 times -3 plus 5, which is -6 plus 5, or -1. And then I just get the last one. Since it's at 4 terms, I'm going to go get a sub 4. So I'm going to replace all those little n's with a 4. That's 2 times a sub 3 plus 5. A sub 3 was -1. So 2 times -1 plus 5 is equal to 3. Okay, so that recursive is just using a previous term. And if you write nice and neat, they're pretty straightforward. All right, so review. Just to be very clear, these formulas are given to you. You are not memorizing them. They're on the formula sheet. For any test and quiz, they're on the front board there on the left. These are always given. So if it's arithmetic, our rule is a sub n equals a sub 1 plus n minus 1 times d. Okay, and to write that, you need a sub 1 and the difference. If it's geometric, we have a sub 1 times the ratio to the n minus 1. And this time we need a sub 1 and r. And again, that's just a quick review. We've done this many times. And those are given to us. The one that's not given, the one that you have to memorize or be able to come up with, is the recursive. Or talk yourself through. So you do have to make sure you memorize any of this recursive stuff. You have to do 2 things. You have to state a sub 1, and you have to state the rule. Okay, and this is not on the formula sheet. It never will be. It won't be on the board. You got to know it. So if it's arithmetic, I'm going to say a sub 1 equals whatever that first term is. Don't put the number sign. Put whatever the first term is. And then the rule. So if I want to find a sub n and it's recursive, I'm going to say, okay, what's the previous term? A sub n minus 1. And then what am I doing in my pattern? What number am I adding? So plus d. And it's just done. If it's geometric, it's going to look very similar. I'm going to say state the first term. And then I'm going to say, okay, if I want a sub n, what's its previous term? A sub n minus 1. And then in geometric, we're not adding, we're actually multiplying by that ratio, which we talked about yesterday. Okay, so your goal is first determine if it's arithmetic or geometric, and then find the difference or ratio and write your rule. So the next set of examples, it wants us to write both an explicit and a recursive rule for each of the following patterns. So let's kind of zoom in on this first pattern. How am I going from -12 to -9 to -6 to -3 to 0? +3, excellent. So we said a +3 makes sense to each one. Okay, nice catch on that pattern. Therefore, if I'm adding, that's my difference. The difference is 3. And I'm adding, so it's arithmetic. So I'm going to put an A there. It's arithmetic, the difference 3. I have a list of numbers, so a sub 1 is obvious. A sub 1 is the first term, which is -3. 12. And then I'm just going to write my rule. So for explicit, I'm just going to go right to this rule and plug in everybody. So a sub n equals my a sub 1, negative 12, plus n minus 1 times 3. I can multiply these together. So I've got negative 12 plus 3n minus 3. So a sub n equals 3n minus 15. Okay, and if it's arithmetic, remind yourself we want it to look linear. Okay. Now to write the recursive rule. All right, I'm just going to have to memorize the formula. I have to state two things. I'm going to restate the first term. So a sub 1 equals negative 12. Okay, and then I'm going to say if I want a sub n in a recursive, I need the previous term, so a sub n minus 1. And then whatever I did to get from number to number to number. And we just heard we were going to add 3. And it's done. So I'm stating the first term, and then I'm taking the previous term and whatever I did to my pattern. Add 3. All right, so again, this should all just be a nice little review here. Take a look at 2. I'm going from 15 to 215 to 415 to 615 to 815. How are we getting there? Excellent. So quick add 200. Hopefully those arithmetic ones are nice and obvious. Okay, so I'm adding 200, adding 200. It works every time, hence the word common difference. So my difference is 200. A sub 1 is 15, and then throw it in the formula and clean it up. So throw it in your explicit formula. So I've got 200 and minus 185. And again, it should look linear. We said it was arithmetic. We were adding a certain amount, which means it's got to look linear. To get that recursive, we're going to do those two things. We're going to state a sub 1 is 15. And then we're going to state the rule. We're going to take the previous term, a sub n minus 1, and just tell the reader what we did. We added 200. And we're done. All right, take a look at pattern number 3, 2 to negative 2, 2 to negative 2. How are we changing these? What about negative 1? Multiplying by negative 1. Okay, so I'm going times negative 1, times negative 1, times negative 1. So that is not arithmetic this time, that's geometric, and I now have a ratio of negative 1. Okay, I'm multiplying by negative 1. A sub 1 is equal to 2, and then we'll just plug it, bless you, in the formula. A sub n is equal to a sub 1 ratio to the n minus 1. And geometrics are so much nicer. There's literally nothing to clean up because this base is attached to this exponent, and we know we can't multiply those, so it's just done. Okay. Then we need our recursive formula. So again, I'm going to state a sub 1 is equal to 2. And then I'm going to take my previous term, a sub n minus 1, and just tell the grader what we did to get from term to term. We didn't add this time. This time we're going to say we're going to multiply by negative 1. So we're just saying take that term and multiply by negative 1. That's it. Recursives are easy. There's nothing to clean up. You're just writing it down and what you're doing. Absolutely. Friday. What's going to be what we did yesterday and today and the mortgages. I'll put it all together. And then tomorrow's. All right, try one more, number 4 there. 81 to 27 to 9. Figure out if you're adding or multiplying. Hopefully through adding out pretty quickly. We're definitely multiplying. Our numbers are getting smaller, so hopefully you're thinking your answer is a fraction. What are we multiplying by? Excellent. So multiplying is geometric. So that's the ratios 1/3. A sub 1 is obviously 81, that first term. And we're just throwing it in the formula. A sub n equals a sub 1 ratio to the n minus 1. And again, we're done with the geometric. There's nothing to clean up. Recursive, a sub 1 equals 81. And then we're going to take each previous term and multiply by 1/3. And that's how I get that pattern. You have to, yes, to get any credit. So that's what I kind of put here in that start. You have to say a sub 1 in the rule. Okay. All right, so obviously you can see it written out like numbers like this. They've also given it to us in a graph many times, so I'm going to skip down to 7b here. Okay, just looking at this graph, am I anticipating it to be arithmetic or geometric? Why arithmetic? It's linear. It's a line. So you've got to right away think this is arithmetic. Okay? When I'm looking at A, it creates that exponential, which is telling me right away it should be geometric. And that's something we kind of reviewed yesterday. All right, we've got to know that geometric is my exponential, arithmetic is my linear. We're going to do it in 1 second. Okay? So this 1 here represents my first term. What is the height of my first term? 1, so I can just write the pattern out. My second term, a sub 2, I'm going to roughly estimate to be a height of 2. A sub 3, I'm going to call that a height of 3, 4, 5. So as I see that pattern, what is my common difference? Plus 1. So my difference is a positive 1. A sub 1 is 1. I'm just going to throw it together. A sub n equals a sub 1 plus n minus 1 times d. 1 plus n minus 1. I think a sub n is just equal to n. And then throwing the recursive in there. A sub 1 equals 1. A sub n equals the previous term. And what we did, we said add 1. So we have our explicit and our recursive. And again, linear is arithmetic because it has the same slope. That's the difference. Remember, the difference is the slope. And the geometric is my exponential. All right, next page. I just went through and grabbed just a whole bunch of different Regents questions. So all of these are questions that we've seen on our exam that we should be able to tackle. So starting with number 8. Write an explicit rule for each sequence. So right now this is not explicit because right here you see this a sub n minus 1. This is recursive. So this is saying take the previous term and do what to it? Okay, so is it arithmetic or geometric? Arithmetic, so that should be caught right away. This is arithmetic because we're adding or subtracting. Our common difference is subtract 2, a negative 2. And they gave us a sub 1, so we're just going to throw it in the formula. A sub n equals a sub 1 plus n minus 1 times the difference. I'm just going to clean it up here, I guess. Negative 5 minus 2n plus 2. I'm going to get negative 2n minus 3. Now again, how do you know if you're right? Well, if I plug in a 1, what do I want my answer to come out as? Negative 5. So if I plug 1 in here, that's negative 2 minus 3, comes out as negative 5. I know I did it right. Looking at B, so again, I know I'm in a recursive because I see this a sub n minus 1. I see the previous term, and they're saying take that previous term and do what with the 2? Multiply by 2. So the second I say multiply, I now have geometric, and it's no longer a difference, it's the ratio. Ratio is 2. Okay, so I've got a sub 1, I've got the ratio, so just throw it in the formula, a sub 1 ratio to the n minus 1. So again, each of these came from an exam. That's why we're going to make sure we go through each of these on this page here. Number 9. They say write a recursive rule. Okay? So when I'm writing the recursive rule, I need what I'm doing and a sub 1. So right now, I definitely don't have a sub 1, but I do have this r equals 2. So is this geometric or arithmetic? Geometric. Obviously, the ratio is 2. So I'm going to start with all I can really do is start with the formula. A sub n equals a sub 1 ratio to the n minus 1. Clearly, I can plug a 2 into the letter, the r, the ratio. And all I have is this number, so I'm going to have to use it. So I'm going to say a sub 15 is equal to a sub 1. My ratio is 2, and I'm replacing every n with the number 15. And now I know a sub 15 is 16384 equals a sub 1. And what am I going to type in my calculator here? 2 to the 14th. I don't know that one off the top of my head. 2 to the 14th is, oh, that's nice, 16384. And then to solve for a sub 1, obviously I'm just going to divide over 16384. And a sub 1 is just equal to 1. So now I can write the recursive formula. I have to state a sub 1. And then recursive says take your previous term, a sub n minus 1, and say what you did. Ratio's 2, so we are multiplying by 2. Taking the previous term and multiplying by 2. Sure, absolutely. Absolutely. All right, let's jump down to 11 so you can see it asked as a multiple choice version. After Roger's surgery, his doctor administered pain medication in the following amounts of milligrams over days. So days, dosage of medication. How can this sequence best be modeled recursively? There's your trigger word. Okay. Looking at your 4 choices, this should be a 50% question here. What 2 choices can I eliminate? The non-recursives, which would be which 2? Maddie? 2 and 4 are out. Those are explicit. Those are given to you, and they literally say explicit on the formula sheet. These are your recursives, where you have to state a sub 1 and the rule. So now let's look at the difference. They're saying a sub 1 is 2,000, which is correct. They both are correct. The first term is 2,000. This one's saying take each term and subtract 320. So let's start with our first term. Throw 2,000 in your calculator. Subtract 320. What do we get? 1680. Now, does it have to work for one term or for all of them? Okay, so take that 1680 and subtract 320 again. Does it work? Okay. Do you know why they put this one first? To trick you, because you're going to see it works on the first one, and you're going to get excited and circle it, and they got you again. All right, so be careful. Make sure it works for all of them. So that's clearly out. Let's just verify this one works. Start with your 2,000 again. Multiply by 0.84. Do we get that 1680? And then take that number and multiply again by 0.84. Are we getting this? And then just verify one last time. You want it to work for all, obviously. But that's exactly how I would whittle that question down. Okay. All right, number 12. This one's a little sneakier. A tree farm initially has 150 trees. So what are they telling you that represents? A sub 1, excellent. Each year, 20% of the trees are cut down and 80 seedlings are planted. Which recursive formula, again, circle that word, I'm looking for recursive. Which recursive formula models, we want the number of trees. Okay, so just based off the word recursive, which 2 choices are we eliminating? Again, 3 and 4 are explicit. We nailed them, they're out. Okay, so at least if you had to make an educated guess, like, you're close here. It's 50-50 at this point. All right, so they both say you're going to start with 150 trees. This one's multiplying by 20%, and this one's multiplying by 80%, and then adding 80. So the difference is the percentage. Now, what are we trying to find? Which formula models? We want trees. So am I going to multiply by 20% or 80% if I want trees? Why 80 and not the 20? Right, 20% are being cut down. You're taking those away. We don't want those to be taken away. We want a formula that represents the number of trees. So we actually want to multiply by 80% and then add the 80. Okay, this is taking those trees away. That's not what we want. We want to multiply by 80% and add the 80. All right, looking at, let's go to 14. Okay, and this is like as sneaky as it can kind of get. Find the third term in the recursive sequence. And again, it's recursive because we see something plus something. And they gave us a sub 1. So obviously your gut's saying you want to find a sub 2. Now, however, what happens if I plug a 2 in? Who do I actually get? I get a sub 3. That's not helpful. I needed to say a sub 2. So what number am I actually plugging in? Did you just throw a negative out there? I think we got to plug in a 1, because in order for this to say a sub 2, this would have to be a 1 plus a 1. So I have to let k equal 1. So I'm going to say a sub 1 plus 1, that's how I'm going to get a sub 2, is equal to 2 times a sub 1 minus 1. So now I'm getting a sub 2 is equal to 2 times 3 minus 1, which will get me 5. Now eventually I have to get to a sub 3, it says, right? I want the third term. What am I going to plug in next to make this say a sub 3? 2. I have to plug like k equal 2. So I'm going to say a sub 2 plus 1 is equal to 2 times a sub 2 minus 1. So now I've got a sub 3 is equal to 2 times 5 minus 1. A sub 3 should equal 9. Good. Okay, and that's the final answer. But you got to be careful. If it doesn't start with just a k or an n or whatever, be very careful. All right, for the homework, it's not a ton. We're going odds plus number 16. Okay, so odd questions plus number 16. However, if you're not putting it on scrap paper, make sure you show me tomorrow so you're getting credit for it. And I'll check any homework that needs to from the book tomorrow. But odds plus 16. And then we're still going test Friday, okay? Odds and 16.